All right, so we talked about prime numbers. You learned all about that. You have now taken a quiz on it. We're moving on. We're ready for composite numbers. Composite. When a number is a composite number, it has, ready for this? Ready? 3 or more factors. 3 or more. Can it have 2? No. 2 is a prime number. If it has 3, it's composite. If it has 4, 5, 6, 7, 8, 9, 10, 12, however many you want, it's composite. As long as it has at least 3, we now have a composite number. All right? We're going to go through and we're going to practice some of these, see if we can figure it out. So, let's start with the number, let's start with 4. 4 is the smallest composite number we have. I'm telling you right now, it's composite. But let's look at it and see what the factors are. When we have 4, we can do the factors of, well, 4 times 1, right? We have 4 and 1. And 4 is also equal to 2 times 2. When I write these factors, do I write 4, 1, 2, 2? Or can I just write 4, 1, 2? Or I would put it in order and I would put 1, 2, 4, right? The 1 multiplied by the 4 gave me 4. Even though I have 2 times 2 here, I'm not going to write 2 times 2 twice. I'm just going to make my little tiny rainbow because I know it's multiplied by the same thing. This number only has 3 factors, but it is composite because it has 3 or more factors. We now have 4 as a composite number. This is the smallest composite number you may have, okay? We can get a lot bigger though. We can have numbers like 72. 72 can have a lot of different factors. First, 72 would have 72 times 1. 72, my set was looking a little funky, could also be 2 times 36. 72 is also equal to 3 times, oh no, I know it's equal to 3 because I know 7 plus 2 makes 9. So I know it's divisible by 3, but now Miss Farm is going to actually have to do some extra math in her, outside her brain. And I'm going to do 72 divided by 3 equals 24. Just a little extra math. You guys don't have to worry about that yet. Long division. Don't think about it. Don't think about it. Miss Farmer just wasn't ready for that problem. We also can do 72 is equal to divided by 4 times 18, and 72 is equal to 6 times 12, and 72 is equal to 8 times 9. And now that 8 and 9 are next to each other, I know I went through all of them. Those are all that we could possibly have, and then I would write my factors out here. 72 is clearly a composite number, right? We have way more than 3 factors, so it's composite. We have a 1, a 2, a 3, a 4, a 6, an 8, a 9, a 12, 18, 24, 36, and 72. If we rainbow this up, we will find that each of our factors has a pair. Look at that. We just factored 72. And we figured out that it was composite. We're going to change gears just a little bit, all right? Because finding that it's composite, pretty easy, right? This wasn't hard. As long as it has 3 or more factors, we know it's composite. But now we're going to change gears and we're going to shift into making factor trees. Because this is not only fun, but it's important to know how to do. So factor trees. Factor trees take a composite number and break them down and break down all of their factors into the most prime numbers you can get to. So it's going to be really interesting when I show you how this works, but you got to stick with me for a minute. We're going to take a number that's simple, like 12. We'll start with 12 again. I know we did that in the prime video. We're going to do it again. If we start with 12 and we do a factor tree, we split it into two of the factors. You guys can pick any of the two factors. And I'm going to show you doing it with different ones. So we, first off, never pick the 1. That's boring. You just end up being at the same spot. So instead of doing 1 and 12, let's do 2 and 6. 2 is a prime number. It's as small as it can get, right? We can't split 2 anymore. What about 6? Good, we can split 6. 6 becomes 2 and 3. Those are the factors of 6. 2 times 3. Very good. So right now, these are the primization of 12. And if I did this, 2 times 2 times 3, I would still end up with the answer of 12. Wait, don't believe me? Watch, we can do it with different factors as well. If I did 12 again, but instead of splitting it by 2 and 6, I split it by the other factors it has, 3 and 4, right? Those are different factors. 3 is already at its prime. It can't get split any smaller, it can't get any littler. So that's already prime. 4 can get split. We know this because we just found out it's the first composite number. What can we split 4 by? 2 and 2. Okay, so we ended up with the same primization that we did before. This will work in any composite number ever. It's called finding the primization using a factor tree, and you guys will be doing this, so pay close attention. You can do it for big numbers, you can do it for small numbers, you can do it for literally any numbers ever. So we just did 72. I think you remember that. It was a lot. It was a long process. Let's do 72 again and split it into factor tree. Personally, I'm going to take 8 and 9. Those were factors, right? And they were kind of the easiest factors to work with. They were the smallest ones. How can we split 8? What's 2 factors of 8? 2 and 4. I like that. Good job. Because 2 times 4 equals 8. 2 is as small as it can get. We're done. What about 4? Right? 4 is not. We need to split 4 again. And you already said it. 2 times 2 equals 4. Now this whole side is done. Do you see that? We're at prime number, prime number, prime number. We're good. Let's split our 9. 9 is equal to what? Only one factor besides 1 and 9 works for this, right? 3 times 3. And 3 is a prime number. It is factored out. Guys, if I got a calculator right now and I did 2 times 2 times 2 times 3 times 3, we would find out that equals 72. Don't believe me? All right, give me a second. We'll pull up the calculator quick. Here's the calculator. Are you guys ready for this? We have the numbers 2 times 2 times 2 times 3 times 3 equals 72. Told you guys. I promise it works every time. So never fear. You guys are going to do factor trees. And if you need to double check yourself, get out the calculator and double check. If your factors, when multiplied, your primization factors, when multiplied together, if they don't equal the number you started with, you did something wrong. Go back and double check it. You guys can watch this video multiple times. I'm going to create another video that's just called factor trees, where I do more examples of factor trees. So if you want to go to the YouTube page and check that out, you totally can. If you feel like you're prepared and you're good, go to the seesaw activity and complete your activity today. All right? Good luck, guys. Have fun.